Good morning, ma'am. I'm here to represent you about the power series method. Power series method is a method seeking a solution for a differential equation using power series in the form of y is equal to summation of x is equal to 0 to infinity c sub n x raised to n, which is also equal to c0 plus c1x plus c2x squared plus c3x cubed plus so on and so forth. Now we will solve this differential equation using power series method. So first step, we will let y is equal to summation of n is equal to 0 to infinity c sub n times x raised to power of n. Now this say that we have second derivative. How to get the derivative? We will use the derivative property xn is equal to n xn minus 1. So we will use this property to solve our first derivative. We have y sub 1 is equal to summation of n is equal to 1. We start with n is equal to 1 because it is our first derivative. We apply the property n cn x raised to n minus 1. This is only our first derivative. Now we get the second derivative. We have y squared is equal to summation of n is equal to 2 to infinity n minus 1 c sub n x n minus 2. Now we have the values. Second step is to substitute. Step 2, we will substitute the values. We have y, second partial derivative of y is equal to 1. We equate the equation to 0. Now we substitute here. We have summation of n is equal to 2 to infinity n minus 1 cn x raised to n minus 2 minus summation of n is equal to 0 to infinity c sub n x raised to n is equal to 0. Now we will notice that n is equal to 2, n is equal to 0 is not similar. And also in here, n minus 2 and raised to n. Now to make it similar, we will minus 2, n is equal to 0. Now we can, the values that we subtracted here, we will add it here in the equation. N plus 2, n minus 1 plus 2, cn plus 2, xn minus 2 plus 2, minus summation of n is equal to 0 to infinity cn xn is equal to 0. Simplify, we have summation of n is equal to 0 to infinity n plus 2 n plus 1 cn plus 2 xn minus summation of n is equal to 0 to infinity cn xn is equal to 0. Now they are similar, we can factor it out to get our recursion relation. We factor it out, we have n plus 2, n plus 1, c sub n plus 2, xn minus cn equal to 0. Now we will use this formula, n plus 2, n plus 1, cn plus 2, minus minus Cn is equal to 0. We will arrange this. Cn plus 2 is equal to Cn over n plus 1, n plus 2. This will be our recursion relation. We're done for our step 1 and step 2. Now we proceed to our step 3. Substituting our values to get our values also. Now if n is equal to 0, we have C0 plus 2 is equal to C0 over 0 plus 1, 0 plus 2. C0 is equal to 1 times 2. Now we can notice that it can be also equal to 2 factorial. Next, n is equal to 1. C1 plus C2 is equal to C1 over 1 plus 1. 1 plus 2. C1 over 3 times 2. We notice that it can also be equal to 3 factorial. Next, if n is equal to 2, C2 plus 2, C2 over 2 plus 1, 2 plus 2, C2 over 4 times 3. Can also be equal to 4 factorial. If n is equal to 3, C3 over 3 plus 1, 3 plus 2 equal to C3 over 4 times 5. Can be 5 factorial. Now we notice that C0 over 2 factorial and C2 over 4 factorial will be substitute our C0, which is also equal to C2. This is also equivalent to C2 over 4 factorial. In this equation, we can generate our even coefficients. Y is equal to C0 times 1 raised to n over 2n factorial. We notice that C1 over 3 factorial is an odd number, and C3 over 5 factorial is also an odd number. So we can derive our odd coefficients. We have y is equal to C1 times 1 raised to n over 2 n plus 1 factorial. Now from this one, we can have our equation. Y is equal to C0 1 plus 1 over 2 factorial x squared plus 1 over 4 factorial x4 plus so on and so forth, plus our odd coefficient C1 x plus 1 over 3 factorial x cubed plus 1 over 5 factorial x raised to 5th. Now this will be our formula. Notice that this is also equivalent to the transcendental function. C 0, hyperbolic cosine x plus C1 hyperbolic sine x. This is our final answer. Good morning, Mom. I'm here to represent power series method. Power series method is a method seeking a solution for a differential equation using the power series. Y is equal to summation of n is equal to 0 to infinity Cn x raised to n, which is also equal to C0 plus C1x plus C2x squared plus C3x cubed plus so on and so forth. Today we will solve y, the second derivative of y, plus y is equal to 0. We will solve this differential equation using power series method. First step, let y is equal to summation of n is equal to 0 to infinity c sub n and n x raised to n. To get our first derivative, we have to follow the property of the differential n x n minus 1. Second derivative of y, we have n is equal to 2 to infinity n times n minus 1 Cn xn. Now, for the second, you have to substitute. Pause na. For our second step, we have to substitute the values. Second derivative of y plus y is equal to 0. For second derivative, summation of n is equal to 2 to infinity n times n minus 1 c sub n x raised to n minus 2 plus summation of n is equal to 0 to infinity c sub n x raised to n is equal to 0. Now we notice that n is equal to 2 and n is equal to 0 is not similar. And also the power of the x, it's not similar. So what do? We minus 2 in here, so that becomes 0. Summation of n is equal to 0 to infinity. Now whenever we subtract the values in here, we will add the values here. N plus 2, n minus 1 plus 2, c sub n plus 2, xn plus 2 minus 2. Now summation of n is equal to 0, cn xn is equal to 0. We simplify, we have summation of n is equal to 0, n plus 2, n plus 1, cn plus 2, and xn. Now summation of n is equal to 0 to infinity cn x raised to n. Now this one and this one is similar. This one and this one is similar. We will factor out so that we get our recurrence relation. N is equal to 0. N plus 2, n plus 1, cn plus 2, plus summation of n is equal to 0, cn xn is equal to 0. Now, notice this and this is similar. Can factor out n plus 2, n plus 1, cn plus 2 plus cn is equal to 0. Now, based from here, we can have our recurrence relation. Cn plus 2 is equal to Cn over n plus 1, n plus 2. This will be our recurrence relation. Now, our third step, we have to substitute and make up for the values of our recurrence relation. So, if n is equal to 0, c sub 0 plus 2 is equal to negative c sub 0 over 0 plus 2, 0 plus 1. It will be negative c0 over 2 times 1. It can also be equal to negative c0 over 2 factorial. Now, if our n is equal to 1, we have c1 plus 2 is equal to negative c1 over 1 plus 2, 1 plus 1. It will be equal to negative c1 3 times 2. It can also be equal to 3 factorial. Negative c sub 1, 3 factorial. Now, if our n is equal to 2, we have c2 plus 2 is equal to negative c2 over 2 plus 2, 2 plus 1, which is also equal to negative c2 over 4 times 3. Notice this, we can have this as 4 factorial. Now, if our n is equal to 3, we have c3 plus 2 is equal to negative c3 over 3 plus 2, 3 plus 1 will be equal to negative c sub 3 over 5 times 4, which will be also equal to negative c3 over 5 factorial. Now, we can notice this in this is also equal. From here, we can derive our even coefficients. Y is equal to C0, negative 1, n over 2n factorial. Now, our C3 and our C1 can be also equivalent. We can derive our odd coefficients. Y is equal to C1, negative 1, n over 2n plus 1 factorial. Now, from here, we can derive our whole formula. C0, 1 plus 1 over x plus 1 half x squared minus 1 over 4 x raised to 4 plus so on and so forth plus C1 x plus 1 over 3 x cubed plus 1 over 5th x fifth plus so on and so forth. Now, as we notice, this can also be equal to the transcendental function. Y is equal to C0 hyperbolic cosine x plus C1 hyperbolic sine x. this will be our final answer. This is the end of my presentation. Thanks for watching.